of yesterday. Example 1 and 2. Example 1 says, find all rational zeros. Here's your polynomial. How do I know this is a polynomial? All your x's have positive exponents, none are under a radical, none with a negative exponent. So we have a polynomial. This is a function. We are looking for the rational zeros. What are the rational zeros? The rational zeros are numbers like 1, 2, 3, 4, -1, -2, -3, and all the fractions. You should know what a rational number is. Read question 2, or example 2. It says find the real zeros. The real zeros include the square root ones. Just as long as you do not have a negative under a radical, those are imaginary. So you have to read the question. We did this one yesterday. So on your test, you're going to have one that's going to say find the rational zeros. If it said find the rational zeros, what you do is you start off with your possible zeros. Do you remember how to do the possible zeros? You take the factors of the constant, which is 6, which are 1, 2, 3, 6, and the negatives, over the leading coefficient factors, so 1 and 2. So with this, does everybody understand how to make a list of all your possible zeros? You're going to take 1 over 1, 2 over 1, 3 over 1, 6 over 1, and all the negatives. And then you do 1/2, 2 over 2 is 1, 3 over 2, and 6 over 2. So one at a time, what you have to do, this is what we did, we took a possible zero and we tested it by using synthetic division. Be careful that if you are missing a term, you put a 0. So we did 1. 1 did not work. How do I know it doesn't work? Because you don't end up with a 0 here. Then I tried -1, and I stopped midway because I knew I wasn't going to get a 0. Then I jumped to 3, the number 3. And I said, hey, 3, look what happens with the number 3. I get all positive numbers down here. So what do we call the number 3? It's an upper bound. When you test a number, a positive number, and you have all positive numbers down here, that number's that's an upper bound. That means that number's too big. If it's too big, then do not try. You can cross 6 out. Does everybody understand that? And I wrote up here, an upper bound is when you test a positive number and you get all positive numbers at the bottom. A lower bound is when you test a negative number and you get a checkerboard, positive, negative, positive, negative. If you have a lower bound, that number's too small, try something bigger. So you're going to want to look at those kinds of tests, upper and lower bound. Why? Because if your list of possible zeros is enormous, are you going to want to test the number 6? And let's say this happens to be a 12. You're going to have a lot more, or a 36, something like that. You're going to want to throw out anything you don't want to waste your time testing. The goal is to find the first 0, because then you're going to chisel away at it. So I did -3, and -3 resulted in a 0 here. So we found one. We found a 0. So how do you write this in factored form? If -3 is a 0, you're going to write x plus 3. Remember, it's the opposite. So if you had this factor, -3, see how it matches? It's the opposite. What you have here is important because this is going to give you the coefficients 1 degree less than what you started with. Now everybody look at this right here. We are now trying to break this up. How are we going to break this up? Look at your constant and your leading coefficient. It's a 2 here and a 2 here. So your list of possible zeros has been reduced. Don't go back to this list of zeros. Especially in a situation like this, we don't have to test 6 or negative 6, even though we found it to be an upper bound, because it's not here. Okay? Now, the other important thing, see how 1 did not work and neither did negative 1? It didn't work at the beginning. Don't try it again. If it didn't work the first time, it cannot work the second time unless you made a math error. Okay? So, see this list of possible zeros here now? Basically, all you have to try is the 2's. And now let's say you would have tried 2 over here at the beginning and it didn't work because it doesn't. You don't have to try those either. Because if it didn't work the first time, it's not going to work the second time. So now we try a half. You could try a positive 1/2 or negative 1/2, and 1/2 worked. So we have 2 zeros so far. We have negative 3 and we have 1/2. So in factored form, that's what you have, x minus a half. What's left is 2x squared minus 4x minus 4. Then what do you do at this point? When you have reduced your polynomial to an x squared problem, this is where you're going to jump into either you're going to either simply factor it, which I see a 2 that can come out. And now try this. Can you simply factor this? No. I don't know what times what is negative 2, but adds to be negative 2. This is not simply factorable. Can't do that. So what are you going to do? You're going to use the quadratic formula. Or you can, at this point, you can complete the square. Complete the square, because I think you guys need to see this again. How would you complete the square? Because this is actually easier. Why is this easier to complete the square? When the leading coefficient is 1 and the negative, if this is an even number, it's easier to complete the square. So we would add 2. So this negative 2 becomes a 2 over here. You take half a negative 2 and square it. You get 1. You're going to add that number to both sides. Factor. And now you are going to simplify. Don't forget plus or minus and add 1. Okay, now this is important. See these 2 zeros? Are they rational zeros? They are irrational. So these are real zeros. When they're not real, you'll have a negative under the radical. So to answer question 1, it says, find all the rational zeros. Your answer is only negative 3 and 1/2. Question 2 says, or example 2 says, find all the real zeros. It's the same question. I hope you realize that was the same one. What would you answer on this? You would say it's negative 3, it's 1/2, and it's these 2. These are real zeros. The third question you will be asked is question 3, example 3. Factor that polynomial. So if you were to factor this polynomial, what would you write for this answer? These are the 3 questions you're going to be asked on your test. How would you write this answer factored completely? X plus 3, that is correct. X minus a half, that is correct. 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 And there's one more little thing you got to bring down. That 2. Yeah, we pulled it out just to factor that trinomial. Yeah, put it out in the front. It doesn't look right sandwiched in here. You put it out in front. It's just where you your shoes backwards. Can you wear your shoes backwards? Yeah, it just looks goofy. Or your clothes backwards. It's just, this is just mathematically, you don't stick it right in between there, you just put it on the front. Okay? Are we good? So, there's going to be 3 questions on your test. On this section. Read question number 1 in your homework. One will ask you this. I'm gonna go through the whole, what's on your test. So everybody look at question number 1 in your homework.
Val, don't you talk.
Okay, I want you to read this. It says, find all the rational zeros. So 1 through 11, you're gonna find the rational zeros. You're gonna have a question, it's gonna say find all the rational zeros. So what do you do here on question number 1? Start me off.
Find all the things, possible.
Possibles. So what are we gonna do? Possible zeros are 1 and -1 and so does everyone understand? Basically, we only have 1, -1, 3, and -3. Where do you want to start? 1. You're going to put your coefficients and make sure if there's a missing term, you put a 0. Are you with me? Now, do what?
Bring down the 1,
Then,
multiply by 1, 1, 4,
then what?
multiply by 1, so it's 4, and
Then
then
what?
3, 3.
Okay, now what?
Now that's your factor, 2 factor.
So, what is this?
X
It's a
minus
0. But if you were to write it in factored form, it's x minus 1. What is this right here?
1. X squared plus 4x plus 3.
Okay, now, what are you gonna do?
Well, not triangle, but like diamond.
If you like to do the diamond or however you factor it, what times what is 3 but adds to be 4, and we're getting lucky here on this one. This is a simply factoring one. So, if the question said factor it completely, that would be your answer. But the question said find all the rational zeros. What do you get? 1. Okay. Now, question for you. Let's pretend like this bottom row right here, after we did 1, let's pretend like it said 1, 0, and 3. So we did 1, and that's what we got. What do you have now? You have x minus 1, and then you have x squared
plus 3.
plus 3. Good. Now what are you going to do?
Now you're gonna have a radical. Aren't you gonna have a radical?
Okay.
So that won't even be a rational number, so why do you wanna figure it?
What do you mean it's not?
It's gonna be a radical.
You have a negative under the radical. So this is plus or minus nothing. Okay? So if I ask you this question, find all the rational zeros, what are you going to say?
1.
1. If I ask you to write it in factored form, what are you going to do? You're going to leave it like this. This is a factor, but you can't break this up anymore. Now I'm going to change this around a little bit. What if I gave you this problem? It worked out to be 1, and you had a 1, a 0, and a -3. Now what are you going to do?
X minus 1.
Then what?
X squared minus 3. Plus 3.
Okay, so now the question says find all the rational zeros. What answer are you going to say? Find all the rational zeros. What are you gonna say? And you just did this problem.
Does it repeat?
You got 1. And what else do I write? What else am I gonna write?
I'm not sure if you do that one because it could
Good answer. You're not going to write this here. Why? Because it's not a rational number. Now, if the question said find all the real zeros,
then you put all of them.
then what would you write?
1
A 1.
plus minus radical 3.
There's 3 of them. There's 3 real zeros, but there's only 1 rational. Now, what if I asked you to write this in factored form? Factor it completely. What would you write? Right? Now, a lot of you guys are just used to doing that, but because there's not, the 1 plus root 3, if you wanted to, you could just, drop these, and what's a negative negative? So another good answer would be this, this, and this. Are you with me?
Yeah.
This question on your test is going to be worth it's gonna be a very long one. It's not gonna be that simple, but it's gonna ask you those 3 things. Find all the rational zeros, find all the real zeros, and then factor it completely. And it might be a degree of 6. It's gonna be a full page, and you're gonna have to show a lot of work, okay?
Not fun.
All right, next. We're gonna try number 3. Let's do number 3 together.
Okay.
What would you do on 3?
You find possible ones.
What are your possible ones?
Plus minus 5 plus minus 1.
Okay? So we try, what do you want to try first?
1.
I always try 1. And I actually should not put that part. That was a bad habit. Okay, what do you do now?
Now you write the factor. X minus 1.
Then what?
X squared minus 6x plus 5.
Okay, now can I factor this?
Yeah.
5 times 1 is 5 and adds to be 6. So answer the question. On the test, it's gonna say find all the rational zeros. If you write this as your answer, have you answered my question? Someone in here will probably do that. Okay? Is everybody looking at this? Because I hope that if you're paying attention, you will understand that you don't want to write that as an answer. Read the question. It says, find all the rational zeros. That's not the answer. The answer is,
1.
it's
Negative
positive 1.
5, negative
This is what goes on your answer line. Yes. You could do this if you want. Like that. That's fine. Plus or minus 1 and negative 5.
Wait, so that's what you put in the answer?
If it asks you for the zeros are 1, negative 1, and negative 5. If it says factor it completely, that's this answer.
Alright.
You have to read the question. But a lot of times people will write this as an answer, and I can give you partial credit, but I don't know if you know that 1 is the 0 and negative 5 and negative 1. That's where, it's difficult for me to check that one.
So let's just find out your rational zeros and break it down.
Yes, I want these answers. Read the instructions, find all the rational zeros, and this is the answer right here. So, this is this answer right here, one. Okay, now move on to number 7. What is up with this problem? We have 1/12. We have 1/12. We have 2/3. And we have 1. What are we gonna do with this problem?
How many numbers?
Multiply by 12.
We're gonna multiply everything by 12. 12, 12, 12, what happens here? 3 goes into 12 4 times, so you're gonna have 8x here, and 12 here. So what's your new problem?
X squared minus 8x plus 12.
So, you might see one of these. What are your possible zeros on this one? 1, 2, 3, 4, 6, and 12. Now you may want to look for upper and lower bounds on this, because the list is large. But I'm going to tell you, let's pretend like we did a bunch of them in -3. We're gonna try -3.
Okay.
I have a crystal ball. What happens?
-3, -4.
Jordan, keep telling me not to put that line through. Okay, what are you gonna write? What are you gonna do now? I know, that's why he said that. What are you gonna do?
X squared minus 4.
Okay, now what? Can you factor this? What are your zeros?
That's 3.
I'm just writing this for you. What are your zeros? The
Two.
answer
2 and -3.
would be -3 and 2. Now, this is what you're gonna learn tomorrow, is a zero could occur more than once, and that's its multiplicity. And Jordan, this is what you asked. It's gonna, if you were to graph this polynomial, you'll see at 2, it's not gonna go through 2, it's gonna bounce. So that's just a little bit of what you're gonna do tomorrow.
I have a question.
Yeah.
Do we work on the examples besides the homework?
No, we just did 1 and 2.
That's good.
The examples that are on the previous pages are in your book. We're kind of running out of time, and the only way I'm gonna be able to get your partner test in on Monday is if I'm fast forwarding. I'm gonna even cut some problems out of here. These could take a long time. Look at number 9.
Oh,
Number 9.
But you didn't take 3 pages anyways.
I'm just gonna help you set this up.
multiply by 3.
Right. Multiply everything by 3. Can everybody multiply this by 3? I wanna make sure you get the right equation. What do you do if you multiply everything by 3? What do you get?
X to the 4th minus 3, x to the 3rd minus 3, x to the 2nd plus 13x minus 6.
Good. And now you can finish that one for homework. Okay, how about number 11? Number 11, and I thought we set this one up yesterday.
You just multiply by 10.
Number 11, you're gonna multiply everything by 10. What's your new equation gonna be?
X to the 3rd minus 19x plus 30.
Good job. So now, what is your constant? 30. What are your possible?
Plus or minus 1, plus or minus 2.
Now I do this.
Plus or minus 5.
1 times 30 is 30. then I go, does anyone do this? 2 times 15, then what? 3 times 10, 4 doesn't, but 5 and 6. Huh? When you get to the point where they're in a row, like that, like next to each other, you've done them all.
That's nice.
So 30, 30, 30, and 30. There's no other ones. So now for this one, you're gonna wanna make sure if you, let's say you tested the number 1 and you did this problem and you ended up with all positive numbers here. What is the number 1 called?
Upper bound.
It would be an upper bound, so guess what? By knowing that, don't do 2, don't do 3, don't do 5, don't do 6, don't do 10, don't do any of those, because it's upper bound, okay? And by the way, the first one that works on this one is 2. 2 works. 2 works, and then you end up with 1, 2, and negative 15. And then you can simply factor this to be x plus 5, x minus 3. So the question is, what are the zeros, the rational zeros? What are you going to write?
2, negative 5, 3.
Good? Does anyone have any questions? Okay, look at number 13. I want you to read the instructions. It says, factor the polynomial as a product of linear factors in a factor g of x such that g of x is either a constant or a polynomial that has no rational zeros. So in other words, factor it completely. That's what that means. Factor it completely.
I don't like these.
So if one of these problems were in this section, like for example, number 11, if number 11 was in this section, this would have been the answer right here. This one, they're not asking you for the zeros. They're asking for you to factor completely, okay? So how would you do number 13?
Find all the possible.
Find all your possible zeros. What are they?
Plus or minus 1, plus or minus 2, and plus or minus half.
You are correct. What do you want to start with?
I'd start with 2.
You start with 2? Why not 1?
Because I already did the problem.
Because I already did the problem. Good job. And I already did the problem too, so I'd start with 2 too. So you're gonna bring 2 down. 2 times 2 is 4.
0,
0,
0,
0,
and then.
and 0. Right?
Mm-hmm.
So what do you have now?
X minus 2 times 2x squared plus 1.
Alright, now what are you gonna do?
Now you're going to solve for x with that one.
We're gonna try to solve this for x. So this is our next step. I'm gonna subtract 1 and divide by 2.
And
Then what?
square root it.
And what did you get?
I got plus or minus square root of, yeah, that. But
You
isn't
got
it,
nothing.
but since you squared, like, it says completely factor or whatever, don't you put that in anyway?
These are not real zeros.
Not,
So you do not factor this anymore.
okay.
Did everybody, this is the reason why I wanted to do this one. At this point, you do not have real zeros. They're not real. So you're not going to factor this anymore. It's done. This problem, this would be the answer right here. Now, let me change it around for you. Let me change it around for you. Let's say this answer was x minus 2, and then you had 2x squared minus 1. Now what would you do?
Now you'd have a positive underneath it.
Now you're going to have You're gonna add 1 and divide by 2. Now you get 1/2. And you square both sides. Can you square a positive number? Yep. Some of you remember how to rationalize. If you want to rationalize, go for it. Plus or minus root 2 over 2. That's the same. These two are the same answer, whether it's rationalized or not. I'm not concerned about the rationalizing of the zero. So if you want to just leave it like this for now, that's fine. So now, if this happened, how would you write this in factored form now?
X minus 2 times x minus square root half. Or, yeah,
Just have that as example.
times x minus negative square root half.
Or another answer would be if you drop the parentheses and make this a plus. Okay? Are you guys understanding the different types of problems?
Yeah.
Okay, and we're gonna try 15. Look at 15. And star this one. This is a good one for you to go back and review. What are you going to do?
If possible.
Take out an x cubed. Why do you have to take out an x cubed?
To get the constant.
Basically what you're doing is you're factoring at the beginning. You've got an x cubed common. So if I take out x cubed, because it's a common factor, you get x cubed plus 2x squared plus 3x and then plus 6. You have to have a constant, and you don't have a constant right now. There is no constant, but now you have one. So what are your possible zeros? 1, 2, 3, and 6. When you pull a number out and test it, you're trying to break this piece up right here. So, did anybody do this one yet?
Negative 2.
So x cubed, what number worked?
Negative 2.
Negative 2. So negative 2, we have 1, 2, 3, and 6. You bring down the 1, negative 2, 0, 0, 3, negative 6, 0. So what do you have now? You've got x cubed,
Times x plus 2. Times
X plus 2.
Squared plus 3.
x squared plus 3. What was the direction? Factor completely.
You can't factor it.
Can we break this up? Why not?
Because it'll end up negative.
You're gonna have a negative, so this is your final answer. What if it said, find all the rational zeros? What are you gonna say? What are the rational zeros?
0 and negative 2.
Very good. This is imaginary. You're good. Okay, I want you to look at 19. I'm going to ask you this, I'm changing this around. If I ask you, first of all, what are your possible zeros? 1, 2,
4,
4,
5, 10,
5, 10, and 20. If I ask you, is 5 an upper bound? Or is negative 5 a lower bound? These are two different questions.
We just have to test.
What are you gonna do? One of these will be on your test.
Yeah.
Okay, so what do I do?
Okay.
Do I-
negative.
Okay, so if I asked you this first question, A, is 5 an upper bound? What are you gonna do? Tell me what to do.
5 in that box.
Put a 5, and then what?
And then 1, 2, negative 7, 20.
And then what?
Bring down the 1. times 5 would be 5, 7. Yeah.
What's that? 28?
Well, that's gonna be positive.
5, 40, 10, 140, 160.
Yeah, that's
Okay,
positive.
so my question was, is 5 an upper bound?
Yes.
Okay, you would say yes. And this better be shown. I don't want to hear, I did it in my head. I need to see the proof. And I may ask you why, prove it. This is your proof why. What about, is -5 a lower bound?
You just plug in.
What are you looking for a lower bound?
Positive, negative, positive, negative.
Yep, or negative, positive, negative, positive. So 1, -5, -3, 15, 8, -40, and -20. What would you say to this
Yes.
one? Yes. And your proof is this. What if I ask you this question? Is 5 a lower bound?
No.
What if I said, is -5 an upper bound?
No.
Okay, those are trick questions, right?
Mhm.
Only positive numbers can be upper bound and negative numbers can be lower bound. Okay? Everyone got that?
Yeah.
So for number 20, I want you to test, is -2 a lower bound? You can do that for homework. Write that down. Flip it over. We're gonna skip 21, you don't have to do it. You're gonna do for homework 23 and 27 only. How's that?
What ones? What ones on work?
23 and 27.
23 and 27. Now,
Is it really homework?
read the question.
Real zeros, all of them, isn't it?
Find all the real zeros. What
That's
kind of zeros am I looking for?
all of them.
Okay. I want all the ones, the rational ones. I want all the irrational ones. But I don't want the ones with a negative under the radical. Now I'm going to ask you to do 2 things for me actually 3 things for me on this problem. I want you to answer these questions. Because this is like what you're going to see on your test. I want you to list the rational zeros, even though it says all real. I want to see if you understand the difference. And then I want you to factor completely. So both of these, I want you to do that, and I want to see your work. So if you can do these problems, then I know, at least, you know the differences between the 3 questions. Does everyone understand that?
Yes.
So, you're off the hook for those last 3 problems. And the front page needs to be finished, okay? Does everyone understand? The front page needs to be finished that. Now, as far as, hang on one second. As far as the examples, I was planning on spending another day on this and doing all this, but because of the election on Tuesday, in the way we have to do this, where Monday's your partner test, I'm running short on time. So, we're going to skip those examples, but if you need more help, these are in your book. Try them all, and look in your book and you'll see this is in your book in section 4.2. They're all in your book. You can go through them, and you really should. So everyone all set?
Yeah.
If you're not gonna be here tomorrow, tomorrow, stop by and get the notes, because on Monday, it's your partner test, and you aren't going to be helpful to your group if you're not doing your homework.